Hello there. Thanks so much for joining me this Friday. My name is Julie Hirschberg. I am the owner of Reactive Physical Therapy and Wellness. We are an outpatient neurologic therapy practice, really striving to change the world for people with neurologic disorders, including the people that we work with on a day-to-day basis, but also in chatting, discussing, learning with other healthcare providers, many of you who catch our videos every week. And I just want to thank you. Thanks for joining us, for asking good questions. It drives our learning and what we're doing every week. So I appreciate you so much. I Today we're diving in deeply to some topics that frankly people ask a lot of questions about. And last week, we talked about sensory mapping as one way to start a central nervous system approach to pain and many other disorders like dystonia and functional neurologic disorders. And that was, I put together this little handout that was kind of the backbone of what we talked about last week. I started putting things together for a course that we are doing at Reactive, which is all about central nervous system connectivity and how we can plan our assessment and treatment to drive that process. So then I thought, well, what really is this? What really is central nervous system connectivity? And so we're going to go really big picture today. As like, what is that? Where do we start with our understanding and treatment? So we're going to talk a little bit about what is central nervous system connectivity, what systems come into play when we talk about cultivating that connectivity, and where might we start it in practice? What does the literature say? And by the way, I've been really deep diving into the literature. You're going to have to forgive the nerding out today, big time. So, especially when it comes to this first question, what is central nervous system connectivity? So I have to start with one of my favorite things. I wish you could see it right now. It's in the other room. One of my favorite things at Reactive is a saying that we have on our wall, and it's very much a thanks to Allie Elder. Shout out to Allie, who, when we were thinking about things to put on the wall, this was some of our brainstorming. And it says, hello, brain, hello, body. And very simple. But what I love about this is the way we think about therapy and what we're doing is making, remaking, relearning those connections, specifically between the brain and the body. And also, a big part of that is actually those connections within the central nervous system. And that can be at multiple levels, right? Because the central nervous system is the spinal cord, it's the brainstem, cerebellum, and the cerebral cortex. So we've talked about a lot of those areas. So how are they connected? And we think a lot when we're setting up any of our therapy and even exercise, we think about facilitating or strengthening those connections through experiences in our body, whether those are sensory or motor or visual or vestibular or even emotional. So all of those pieces come into play, and it goes very well. I don't know if you've heard the saying, neurons that fire together wire together. That wiring is all about connectivity. So that's what we're talking about. And I do have to admit, I have an inner skeptic, and that inner skeptic always has to ask, well, how do we know that we're changing connections here? And this is why we need to get to some of the science. And really, just in the last, 10, 20 years, ways of measuring and analyzing this connectivity have really grown. And this is where I have to apologize. It went down a very deep rabbit hole because there's so much exciting things happening in the world of imaging and connectivity. And so there's things from tons of animal models where they're using electron microscopy and a bunch of other fancy tools. And I found a very cool article here that I'll post the link to at the end. So fascinating. So if you want to dive off the deep end with me, you certainly can. There's another really great article that specifically defines functional connectivity in the realm of what that means on functional imaging and in some of these other ways that we measure it in a research realm. And I say we, I'm not doing any of this. This happens in the research world, but I read a lot about it. So in in that world, when they're measuring it, two regions are considered to have a functional connectivity if there's basically a statistical relationship between the measures of activity recorded in them. So sometimes we don't know which direction that goes in, but they're statistically related. And if we go even deeper there, you could get drill down and even be more specific. There's some work from the brain Connectome, which, by the way, there's this great website. I'll post a link in it. It's called the Human Connectome Project. And I spoke with one of the researchers for this project when doing the neuroplasticity retreat with USC. And I they're basically mapping out all the connections in a very beautiful way in the human nervous system. Think about it like the DNA uh, project for the Human Genome Project, but it's the Human Connectome Project for connections in the brain. They have a lot of beautiful images showing these connections. And that can even go very specifically to look at different nodes or regions and macro connections, and then even micro connections between individual neurons. That's not something that I look at. I'm not getting under the microscope of somebody I'm working with and looking at their brain. But we can look at some of the literature here and see what occurs on functional MRI imaging, for example, what occurs with therapy, because this is where it gets really exciting. So there are a lot of great studies that have been coming out with functional MRI in functional movement disorders. So I know double function there. And looking at mechanisms of the disorder. And then very recently, a group that did inpatient rehab study in functional movement disorders looked at fMRI changes and looked at whether those were actually correlated with improvement in their symptoms. And they found, and by the way, I'll post a link to the study here, they found that the improvement in symptoms were associated with increased connectivity, so functional connectivity between places like the amygdala, the ventromedial prefrontal cortex, which were really important. And on the opposite side of that, they found that people who didn't respond as well actually had increased connectivity between the amygdala and the motor cortex. So interestingly, it looks like their motor retraining program seemed to reorganize activity and connectivity in emotion processing and motor planning networks, shifting um, from the pure motor cortex. So that tells us a little bit something. One, it tells us, yes, absolutely, they change central nervous system connectivity, which is so cool. And then they could actually distinguish which of those changes were more effective for people. So that's just one example of many where a targeted therapy was they looked at changing the connectivity. And indeed, they did change the connectivity, which is so cool, and did it through a motor training program. So one of our second questions to talk about is like, how do we direct this change? Is it through the motor system? Is it through the sensory system, the visual system? Is it the vestibular system? Is it through emotions? And this is where that kind of psychosocial approach to everything we do, including incorporating the optimal theory into that, is so important. Is it through the autonomic nervous system? So we have a lot of ways that we might influence and cultivate central nervous system connectivity and changes, which is really the heart of neuroplasticity, right? So the third thing here is, where might we start this in practice? And I think as therapists, we're doing it all of the time. It's not like one thing would works for everyone. We actually really need to assess and see where that person might be needing to make more connections in different systems. Um, but I want to start in the sensory system because I think it gets overlooked. So if you're not sure where to start, even just assessing in the sensory system would be the first thing. And when I say that, I'm thinking sensory connections, not just pure is sensory intact or not, but what about that higher level of connectivity, that posterior parietal lobe function in the sensory system. And, there's a lot of great studies, which I would say are kind of in the orthopedic world here. I mentioned one last week about the frozen shoulder, and they did some of this sensory discrimination training, localization training. And from loads of literature and systematic reviews in different pain groups, like in a group of people with low back pain, phantom pain, CRPS, this cortical reorganization, especially in the sensory system, seems to be part of the piece that needs to be addressed for there to be improvement in pain. And many studies have demonstrated that when sensory training, sensory discrimination training is incorporated into treatment, that there are improvements in pain, which really tells me that we're helping change that map. We're cultivating central nervous system connectivity. And so, loads of, again, I could like highlight many, many studies here. I'll drop a couple into the comments once I'm finished. But when we look at sensory discrimination, along with things like graded motor imagery, those are targeting central nervous system connectivity. And we know that that connectivity, processing multi-sensory experiences, is very important in improving people's pain. And I would also suggest that we would use this in disorders like dystonia, functional neurologic disorders, and many others where sensory discrimination might be impaired. So again, I chatted about this last week, the graded sensory remapping, which is actually out of one of these studies for for shoulder pain. I put this together in a step-by-step. We've been using it for central pain, functional disorders, dystonia, and having a step-by-step phasing program of it has been very, very helpful. So again, I'll put a link in here because I created this and I'd love for you to have it so you can download it for free. It's also just one little piece of our weekend course that we just opened up for people to join in. It's going to be an online course called Cultivating Central Nervous System Connectivity, a guide to assessment and treatment in central pain, functional disorders, dystonia. We have the amazing Dr. Laura Ettinger, Dr. Alan Wu joining us from the physician perspective to understand the medical diagnosis, the differential diagnosis piece, and the medical treatment piece of those disorders, and then going very deeply into the commonalities of the science and the assessment and the treatment from a therapy perspective to drive connectivity. So this today was almost just like a little tiny piece of that, what's going to be a full weekend course. So we just opened it up. As usual, there's an early bird registration. It's actually $100 off, which I think is really great. And that's good through the end of this month, through the end of August. So I hope you'll join us for that course. It's coming up in October, and I think it's going to be pretty awesome. So that's what we've got for you today. I do see a comment in here. Hi, Tammy. Have you ever used interactive metronome? What fires together is wired together. Awesome. Interactive metronome. I'm not sure. I've definitely used the metronome apps on my phone, but I'm not sure if that's what you mean, Tammy. So you might have to drop us a link on which one you're talking about there, because I'm very interested, of course, because the auditory is another one of the systems that provides input into to be integrated in our sensory cortex as well, right? So that's another way that we can influence central nervous system connectivity. So very grateful for you all. Thanks so much for joining me today. And I will see you in the next week. But then we'll be off for a week as I go camping. So have a great weekend, and I will see you soon.